All right. Good morning. Happy Wednesday. Just a reminder, don't be late to class. Watch your attendance. Remember, I'm trying to teach you a little more than math here. I'm trying to teach you life skills. Can't be late to work. You could get in trouble for that. Possibly lose your job if you're late too many times. Also, you can't be randomly absent from work. That's unacceptable. You have to show up to work every day that you're supposed to. If you're absent too much, you could lose your job. So trying to make sure that we're just being responsible and holding ourselves accountable for what's expected. Just to give you, today I'm going to be teaching a new lesson in 11.3, but I'm planning on taking an exam next week on Tuesday morning at 8, 11.1 through 11.3. So that's February 23rd. That's a Tuesday at 8 o'clock in the morning, 11.1 through 11.3. Okay, so the first thing I want to do today is I want to take questions if you have any about 11.2. So I can work a couple problems. Today what we're going to do is we're going to solve radical equations. And I'm going to show you how to check them by hand, but we're also going to use the calculator using the intersect feature to check our answers. All right. Okay. So anybody want me to work any problems from 11.2? I do want to say one thing that you might be getting confused about. Sometimes rational exponents can't be simplified as much as radicals and vice versa. So sometimes you need to change from one to the other if you want to simplify more. If they're just asking you to solve, simplify using rational expressions, then you can just simplify down to that level, but it could be simplified more using the other. But anyhow, anybody want to ask me any questions about 11.2?
In the book on page 552, could you work through numbers first?
Yeah, what page?
552.
552, number?
No, 6.
6? Okay, let me just pen myself real quick. Sorry. Okay. Okay, what is that? I can't even hardly see it. Is it 3y to the 3/4? Two xy to the 3/2, is that right?
Yeah, that's correct.
Okay. All right, so basically, there's nothing to do with the numbers, so just leave that as 3/2. There's nothing to do with the x, but as far as the y goes, you're using the quotient property, which says to keep the y on the top and subtract the exponents. Now, remember when you're subtracting, you have to have a common denominator. So for this guy, you would have to multiply this guy by 2/2. And so your common denominator is 4. So you can rewrite it. Normally I don't. I just say 3 minus 6 is what? -3? Fourths? So 3 minus 6 is -3/4. And now remember that you cannot have a negative exponent. So we're going to flip them to the bottom. So this would be 3/2xy to the positive 3/4. And now what you did just now is you put a radical in the denominator. So for this is fourth root of y cubed. Can't have a radical in the denominator of a fraction. Remember simplifying radicals? Remember the conditions? Can't have that. So the question is, how do you rationalize the denominator? Well, wouldn't it be nice to have a whole number? So the question is, how can we get y squared or y cubed or y to the fourth? When you multiply monomials, you add the exponents. So if I make this y to the 1/4, isn't 3 plus 1 4/4, so wouldn't I get a y to the 1 on the bottom? And that's exactly what I want to do. I want to get 2xy to the 4/4 would be 1. And on the top, you get 3y to the 1/4. Now you might be wondering, hold on a second. Don't we want to subtract the exponents again? No, you get in a vicious cycle. So it's always going to be, it's either going to look like this or it's going to be a negative exponent. And so once you see this, it does meet the conditions for simplifying radicals. And if you notice, this is the answer in your book. You don't have any negative exponents. You don't have any perfect anything under the radical. You don't have a fraction under a radical. You don't have a radical in the denominator like you did up here. See, that's a radical in the denominator. And the index is as small as possible. So this is considered to be simplified because of the conditions. So I'm glad you brought this up because, like I told you, the problems in the book were way harder than anything I did or anything I gave you for practice. But probably where you got messed up is right here. This is a radical in the denominator. You can't have it. You have to rationalize the denominator. And then when you get to this, it's like, hold on a second. Can't we simplify this more? Well, when you try to simplify this more, you're going to get a negative exponent, then you're going to go back to that, then you're going to get a negative exponent, then you're going to go back to that. So there's nothing more we can do. So this is considered to be simplified. Okay, thanks for bringing this one up. All right, anybody else want me to work any problems?
Can you do number 7?
7 on the same page.
I think it's on the same page.
Yeah, it's a radical, right? And what I can't see it. Can somebody read that? Is it the fourth root of 25? Times the cube root of 5. Is that what's there? Can somebody answer me? Because I cannot see the book. So the numbers are too small for me to see.
Yeah, I think that's correct.
All right. Well, first of all, you cannot put those radicals together because they have different indices. So remember, the rule says you can put them under one radical if they have the same index. They don't have the same index. So let's read the directions. It says simplify by writing it using rational exponents. So you're going to change this to 25 to the 1/4. And this is going to change to 5 to the 1/3. And now I can get the bases to be the same. So I can add the exponents, right? So if I write this as 5 squared to the 1/4, wouldn't that be 5 to the 1/2 times 5 to the 1/3? So wouldn't I be able to simplify that by adding the exponents? So I'm going to get a common denominator and multiply that guy by 3/3 and this guy by 2/2. So what I get here is 5 to the 3/6 times 5 to the 2/6 And when you multiply monomials with the same base, you add the exponents, which would be 5/6. And they asked you to do this using rational exponents, so that is simplified. So the whole thing about this is, first of all, you see that with radicals, you can do absolutely nothing. So if you're just working with radicals, you're completely stuck. It tells us to use rational exponents. So the minute you write this as rational exponents, your goal is to try to put these together, right? Simplify means put it together. Make it simple. So you know 25 is a square. So you're going to write it like this, and then eventually you're seeing that you're going to have to put them together by adding the exponents. And so you're going to need a common denominator. Did you follow this or no? Okay, other questions?
I followed it.
Okay. Other questions?
Could you do number 10 on that same page?
And I hope you guys are collaborating with each other. So you should be working with each other. If you're just working individually, that's not going to work in the future. You got to collaborate and help each other solve these problems, because my lesson today is pretty long. And so I want to make sure I get through it. So I don't mind answering questions, but you got to make sure that you're asking questions that you as a group have talked about already and that you as a group haven't been able to do. So just individual questions of not working with each other, that's going to be an issue, because if I don't get through an assignment, I'm still going to assign it. Number 10. Okay, it looks like the fourth root of x something. I can't see this thing. X to the fourth, y to the sixth. What is it, times the square root of x to the sixth? And then it's divided by y. Is that correct or no?
Yeah, that's right.
All right, so once again in number 10, they want us to solve it or simplify by using rational exponents. So if you notice these radicals, you could simplify the radicals, but you're not going to get far. So what we want to do is we want to take x to the fourth, y to the sixth, and raise it to the 1/4 power, and we will simplify that. And then this is going to be x to the 2/6, right? The index is 2 for square root. And then that's all divided by y. Okay, so now I'm going to simplify this first. So x to the 4/4 is x, and x to the 6/4 is y to the 3/2 by distributing, right? Delivering the power, right? You guys follow that? I cross cancel that, and then I divide it by 2 to 3/2. And this would be times x to the 1/3. Okay, anybody have any questions so far? Okay, so now, yeah.
How did you get x to the fourth, y to the sixth, and then to the 1/4?
Well, this quantity, remember when you write it using rational exponents, that's 1/4, right? Or do you not want to write it like that?
No, I understand now.
Well, you don't have to do that if you don't want. If that's bothering you, you could put each of those to the, well, you could either do it this way. You could do it this way, or if that's bothering you and you don't like that, This just depends on who you are. If you don't like that, you could put x to the 4/4, and you could deliver it up here, y to the 6/4, if you prefer to see it that way. Either way, it's the same thing. It's just whatever you feel comfortable seeing. Did I erase something? This is a y, huh? Why?
Miss Birch, wouldn't it be x to the 6/2?
Well, when you're simplifying 6/4,
No, on the second x.
right, 6/2, thank you. 6/2, so that would be, yeah, you're right. 6/2 would be 3, thank you. Yeah, that is correct. Okay, anything else? Does this look good to you guys? Is this what you guys got? Yes, okay. So now what I'm going to do is I'm going to combine the x's first by using the product property, and then I'm going to take care of the y's. So the product property says that when you multiply monomials with the same base, you add the exponent. So that would be x to the 4th. And the quotient property here says keep the y on the top and subtract the exponents, which would be 3/2 minus 1. Well, you're going to have to get a common denominator, right? So you end up with x to the 4th, and this ends up being 3 minus 2 would be 1/2. Did you follow that or no?
I follow. Thank you.
And like I said, there isn't one way to do this. So you guys just asked me, what did I do up here? And I just did it a different way, depending on how you want to see it. As long as you use the properties correctly, there's a lot of different ways to do them. But we kind of, we do want to follow the order of operations. If you notice what I did, I took care of the numerator first, and then I took care of the quotient. So we're doing what we've always done in the past normally, but there isn't one way to do it. Okay, any other questions? Okay, well, like anything, the more you practice correctly, practice doesn't make perfect. It's perfect practice that makes perfect. So if you practice things incorrectly, practice isn't going to do you any good. So it's important that you practice perfectly, and the more you practice, these problems should become easier and easier. All right, so today we're going to solve radical equations. So you're going to see equations with radicals, but you're going to also see equations with rational exponents. And before we get started, I want to look at the calculator, because I want you to be able to check your answers using the calculator, using the intersect feature. So anyhow, I'm in lesson 11.3. Solving radical equations. Okay, guys, this is California Common Core Standard A-REI .2. And I want to take a look at, I want to talk about the calculator right now. So I'm going to make up some problems. If I were you, I would do the explore. And you do want to think about what you have here. So in this example, under y sub 1, we're going to put a square root. And under y sub 2, we're going to put a line, right? Y equals 2. So think about what you have here. You have the square root and a line. You have a horizontal line. How many solutions could you have? Could you have no solutions? Could you have one solution, two solutions, three solutions? So in just thinking about this, I could have no solutions. I could have one solution. Could I have two solutions? I don't think so. So I don't think this horizontal line is going to cross it twice. And by the way, remember, we're not doing an actual graph. We're using a graphing approach. So here's what I want you to do. I want you to grab your calculator and go into the equation editor y equals, and you're going to put in the square root, which is by the square key. You're going to put in the square root of x minus 3, and you close parentheses. Then under y sub 2, you're going to put a 2 and then hit graph. So if you want a standard viewing window, remember you go under Zoom, Z standard. And so this is what I have, and I don't like it because I can't really see it. So I'm going to change my x min to 0. So I'm going to go from 0 to 20 counting by 2s. So I'm going to go into my window, and I'm going to go from 0 to 20 counting by 2s. And then I'm going to hit graph again. And now, see that? That's a lot better. So now I'm going to go into second trace and use the intersect feature. And remember your spider. So you're going to put your spider near the point and hit enter. And then he's going to jump to the other graph. And then you're going to hit enter, and you're going to have the calculator guess, and it says the intersection is 2, 2. So that means our solution is 2. In a minute, we're going to do this algebraically, and you're going to see that this is correct.
Ms. Birch,
Yep.
on the calculator, how do you enter a radical?
Second x squared. Second x squared.
Wait, so did you get 2 for both the x and y solutions?
No, your solution is only x. It's not y.
I got 7 for x. Hold on.
Okay, let's do it again. Let's do it again. Okay, so go into y equal, the equation editor here, y equals. You're going to put in the square root, which is second x squared, and you're going to put in x minus 3. Make sure you put it in parentheses. So don't leave off a parenthesis, it won't work right. Then you go under y sub 2 and put a 2. So your calculator should look like this. Then you're going to go under window, and x min you're going to put a 0, x max you're going to put a 20, and the x scale is 2. Then you hit graph. So now you're going to go to second trace, and you're going to pick the intersect feature, which is 5. You're going to move your spider. See how you can move your spider around with the arrow keys? you're going to move him near the point and hit enter. And he's going to jump to the other graph. So now you hit enter, and it's the calculator says, do you want me to guess? It's not really guessing. And when you hit it, it shows you the point of intersection is 2, 2. Now, because this is a graphical approach, we're not really graphing this. We're looking at the x value is giving us the intercept, where the graph is actually crossing the x-axis in the real graph. So we're only looking at x, just like before when I taught this.
Miss Birch, I still got 7, 2 as the point.
I
Yeah,
got that there.
yeah.
Oh yeah, 7. My calculator says 7, look. I'm having trouble seeing today. I don't know why. My eyes are, 7s look like 2s. I don't know. All right, is that what the problem is? You guys all got 7? It should be a 7.
Yeah.
Okay, good. Sorry. Okay, let's do another problem. Let's do another one. Let's see if I can see. Okay, this time you have 2 radicals. And so just to think about what's going on here, how many times can these intersect? And I'm not sure, but I'm thinking once or maybe not at all. So we're going to go into the calculator again, delete everything out. So clear out everything. And under y sub 1, you're going to put the square root of 2x minus 3 and close the parenthesis. And under y sub 2, you're going to put square root of x. Close the parenthesis. Now I'm just going to leave my window the way it is and let me see what happens here. And mine looks like this. Now you could mess with the y value if you want, but this is good enough. So you go under second trace and you pick the intersect feature 5 and you get your spider. When you hit enter, he's going to jump to the other graph and you hit enter and then you ask the calculator to guess, hit enter. And what'd you get this time?
3.
You got 3 something. Okay, now what we're going to do now is we're going to do these problems by hand and we're going to check them by hand. Now, just a word of warning here. When I give you this test, do not solve these using the calculator or I will give you a 0. So you must show your work the way I'm showing it right now. You can check it with the calculator, but you must show it solved algebraically. All right, so let's put the calculator aside. We do know, let me write these up here. This is square root of 2x minus 3 equals square root of x. We know this answer is a 3, and this answer is not a 2, it's a 7. So you're going to solve algebraically now. And we're going to take square root of x minus 3 and set it equal to 2. Okay, what you want to do is isolate the square. It is isolated, right? And what we're going to do to get, and this is a radical equation because of the variable, not because there's a radical. So let's say, watch this, don't write this down, just look. Let's say you had f of x is equal to square root of 2 plus x. That is not a radical equation. This is linear. So it's a radical equation because the x is inside the radical. That's what makes it a radical equation. This right here is linear. All right, so what you're going to do is you're going to square both sides. Now, here's the deal. Remember, when you square both sides, you have to check for extraneous solutions. So you must check for extraneous or bogus solutions when you square both sides. So remember, a square undoes a square root. So you get x minus 3 is equal to 4, x is equal to 7. Now, there could possibly be no solutions. Now, we do know the answer is 7. So we know that this check's going to work. If you want to check it by hand, you would put the 7 in. So you get the square root of 7 minus 3. Is that equal to 2, the original problem? Is the square root of 4 equal to, is 2 equal to 2? And in a minute, you're going to see me do a problem that's going to take 10 minutes to check on the calculator and 1 second to check it by hand. So everybody who thinks the calculator is so wonderful, you're not going to think it's so wonderful in a problem that I'm going to do. So this is definitely a solution. If the check failed, it would be no solutions. Now, I'm going to repeat this one more time so you don't mess up on the exam. You must solve these algebraically. You can use the calculator to check, but you may not want to. You may want to check it by hand. Okay, let's do the other problem that I did with the calculator. You're solving it, and it was the square root of 2x minus 3 equals the square root of x. If you have two radicals with an x, you want to split them up. So you want them to straddle an equality. And after you do that, you're going to square both sides. That means you have to check for extraneous solutions. So squaring does a square root, so you have 2x minus 3 equals x. If you subtract x, you get an x. If you add 3, you get a 3. So we're getting a solution of 3. And because we did the calculator, we do know this is going to check. It's going to be 2 times 3 minus 3. Does that equal square root of 3? 6 minus 3 is square root of 3. Does that equal square root of 3? Yes, it does. So that is a good solution.
Ms. Bridge,
Yeah.
can you explain what happened to the 2x again?
Subtract x from both sides. You get a 0 and you get an x. Add 3 to both sides, you get 3.
So you subtracted 2x by the x and it turns into x, right?
Subtract x from both sides, you get x minus 3 equals 0. Add 3 to both sides, x equals 3, right? You guys okay? Still using algebra. Still algebra. These are all solving. So you have a radical on one side, you have something linear on the right side if you're going to use the calculator. We are solving this by hand. You have to isolate the radical. So that means subtract 2 from both sides. What do you get when you subtract 2 from both sides, you guys?
You get a 2 on the right, a negative 2 on the right side.
Just tell me what you get. Just somebody read the statement to me.
Square root of x plus 10 equals x minus 2.
Okay, that's correct. All right, now we're going to square both sides. When you square a square root, now you remember that whenever you square, you got to check. So this would be x plus 10 is equal to x minus 2 times x minus 2. You cannot deliver a power across a difference. So this would be x plus 10 is equal to first, outer, inner, last. And now you have to solve a quadratic using one of the quadratic solving methods. So watch this. Subtract x, it goes away. Subtract x gives negative 5x. Subtract 10 goes away. Subtract 10 is negative 6, right? Does this factor? If it doesn't factor, you're going to have to use the quadratic formula. Sometime this year, can you factor? Factoring method 5. Let's go. It's not 3 and 2. 3 and 2 is not going to work.
6 and 1.
All right, and that's going to be a negative 6 and a positive 1 that multiply to give a negative 6 and add to give a negative 5, right? So your possible solutions are 6 and negative 1. And I don't know about you, but I'm thinking about this. With the graphical approach, you have a square root, and that's a line. Can it cross twice? I don't know. I'm not sure. So I'm going to check, and you have to check when you square both sides like that. So I'm going to check 6 first. So 2 plus square root of 6 plus 10, is that equal to 6? Is 2 plus the square root of 16 equal to 6? Is 2 plus 4 equal to 6? Is 6 equal to 6? That is a good answer. So now we're going to check negative 1. So 2 plus the square root of negative 1 plus 10, is that equal to negative 1? Is 2 plus the square root of 9 equal to negative 1? Is 2 plus 3 equal to negative 1? Not the last time I heard. So negative 1 is an extraneous solution. And so you have one solution, which is 6. Now on the calculator with the graphical approach, you're going to see it crossing once. And it will be crossing at 6 something. This right here, on an exam, you have to do this on an exam. That you could do by hand or a calculator. This has to be done on your scratch paper. And I hope I'm making myself clear, because everyone's going to be upset when you get a low test grade and you're going to say, I got the right answer, I got the right answer. I'm going to tell you, I don't care. I wanted to see this and you didn't show it to me. So make sure you're showing me this algebraically. Okay, any questions before I erase this? Let's do another one. That's a square root with a rational exponent. That's another square root with a rational exponent. You are not going to change it to a radical. So you're gonna straddle these. So when you have two radicals, straddle the equality. Did I already write that in your notes? So I'm going to add that one to both sides. So you get x plus 6 to the 1/2. And when you add that, it goes away. And over here, you get 2x minus 4 to the 1/2. After you do that, you're going to square both sides, which means you do have to check. So you're going to take this one. And do you guys see why I'm squaring both sides? See that? They cancel. Power to power, right? So now we have x plus 6 is equal to 2x minus 4. So pay attention. When I subtract x, it goes away. When I subtract x, you get x. When you add 4, it goes away. When you add 4, you get 10. So I'm going to check it. You got 10 plus 6 to the 1/2 minus 2 times 10 minus 4 to the 1/2. Does that equal 0? Do not change them to radicals. So this would be 16 to the 1/2 minus 20 minus 4 is 16 to the 1/2. Well, isn't anything minus itself 0? So this is a good answer.
Ms. Birch, can you tell me what it means? Straddle means?
Okay, it means like if you were going to straddle a board, you're trying to keep your balance in the middle. So what I mean by that is you're putting one on one side and one on the other. So you're balancing the equation by putting one radical on the left and one radical on the right. Sorry, I could have probably used a better word, but I don't know of one right off the top of my head.
I get another one.
Okay, okay. Thank you for asking. All right, do you guys get this? So basically you're just gonna mess with the power and get rid of it. So if this had been, you know, the 1/4 and 1/4, you're gonna take a fourth power to both sides. Okay, so what about the cube root? What about the cube root? Well, guess what? When you cube things, you don't need to check. So cubing doesn't cause extraneous solutions. So we're still going to isolate the cube. Subtract 7, it goes away. Subtract 7 is -2. I just want to make a comment here. If you look up here real quick, If this is a square root, no solutions, right? Because a square root cannot equal a negative. But a cube root can. So when you cube both sides, you don't have to check for extraneous solutions. So anything that's odd, you don't need to check. Anything even, like squaring, fourth, whatever, you have to check. Okay, so here we go. The cube of a cube root cancels it. And a negative times a negative times a negative is a -8. So when you subtract 2, you get -10. And so we're going to see if that works. Now remember, the cube root was sideways, right? With the graphical approach and a horizontal line, how many different solutions can you have? I think you can only have one or none. And it might not even be none, because if you try to escape this graph, it may always run into it. So we don't need to check it, actually, like I said. So this is a good answer. We don't have to check it. So let's look at one with rational exponents. So you isolate the cube root. It's a cube root, right? Don't change it to a radical. We're going to cube both sides. So we have x minus 5 is equal to x plus 1 times x plus 1 times x plus 1, which is some work. So this would be x plus 1 times the FOIL, first, outer, inner, last, would be 2x plus 1. Multiply it out, would be x cubed plus 2x squared plus x squared plus 2x plus 1. And I don't know about you, but I'm praying that we can factor, because if you can't factor, you're going to have to do a P over Q list, and you're going to have to do synthetic substitution. So this is x cubed plus 3x squared plus 3x plus 1. And I'm going to set this thing equal to 0 to solve it. So I have x cubed plus 3x squared. When you subtract x and subtract x, you get 2x. When you add 5 and add 5, you get 6. And like I said, we better start praying that we can factor. So I'm going to try grouping, and I'm hoping that it's going to work. So you take out an x squared, it'd be x plus 3. Take out an x. Sorry, take out a 2x. Would be x plus 3. And it did factor. So your product of factors would be x squared plus 2x times x plus 3. So something's wrong here. Should just be a 2, right? X squared plus 2. Well, if you set x squared plus 2 equal to 0 and you solve it, you isolate the square, you take the square root of both sides and you get plus or minus square root of 2i. Those are not real, right? Right? So we have one real solution, which is -3. So we have 3 solutions. 2 are imaginary and 1 is real. And we're finding real solutions here. Questions about this one? And like I said, this problem would have been messier if we weren't able to factor it. We would have to do a p-list, do synthetic substitution to find one of the solutions, and then get the quadratic to find the other 2, which we would have to use the quadratic formula because these were imaginary. So luckily, we were able to factor it. Okay, now in this lesson, there's some word problems that I want to do that are pretty straightforward. Look on page 562A. And if you guys can read this with me. You know, if you are in a car and you hit somebody, and let's say you put them in the hospital, you understand they can tell if you're lying about your speed or not, right? So whenever you see things on the freeway or taped off, they're measuring skid marks. So in this example we're going to do right now, the driver is saying he was going 55 miles an hour. And we're going to find out if he's lying or not, mathematically. So they bring somebody in to say, hey, this guy, there's no way, the skid mark was this long, this guy's lying, he wasn't going 55 miles an hour. So therefore, if the person dies who was in the car, the driver ends up with vehicular manslaughter or killing someone because he wasn't going the speed limit. All right, so let's check out this problem. The speed S in miles per hour that a car is traveling when it goes into a skid can be estimated by that formula, where F is the coefficient of friction and D is the length of the skid marks. So here's the problem. After an accident, a driver claims to have been traveling the speed limit of 55 miles per hour. The coefficient of friction under the condition at the time of the accident was 0.6. And the length of the skid is 190 feet. Is the driver telling the truth about his speed? All right, so we're going to take the formula, which is the speed equal to the square root of 30 times the friction times the distance, or D is the distance of the skid, right? The length of the skid. So
Yeah.
we're going to fill in the blank. We're going to fill in the blanks. So the speed he's saying is 55, and the, what are they calling it? The F is the coefficient of friction. That's times 0.6, and we're actually going to solve a radical equation. So we're going to find the length of the skid. So we're going to use a calculator because since problems in real life aren't exact, like if I went out and measured the height of my tree right now, it's not going to be 6 feet. it's going to be 6 3/4 of a foot, or it's going to be 6 1/3. Everything in real life is not exact. So lots of times with real life problems, we're just going to use a calculator. All right. Okay. So first of all, I need to know what's 30 times 0.6.
18.
18.
18. Thank you. And we actually have a radical equation, which we're going to have to square both sides. So this ends up being the square of a square root is 18d. And what's 55 squared?
3025.
Thank you. So now when we solve for d, we're going to use our calculator. What is 3025 divided by 18?
It's 168.0 and then repeating fives.
Yeah, 168 is good enough. And what does this tell you?
That the skid marks, if he was going 55 miles per hour, would be 168 and 6 feet.
Yeah. So when they measured the skid marks, they were 190. If he was going 55, like you said, the skid marks should measure 168. So if the driver had been traveling at 55 miles per hour, the skid marks would measure, like you said, 168 feet. Because the skid marks measured 190 feet, the driver was driving faster. The driver was driving faster than 55 miles per hour. And what that ultimately means is that he's lying. And they will have a forensic person come in and say this in court, and they will show evidence that this guy is truly lying, and they proved it mathematically that he's lying, and he will be arrested and put in jail for vehicular manslaughter because he wasn't driving the speed limit if the other driver dies. So yeah, they're not taking anybody's word. They have proof that the driver is lying. So pretty interesting, right?
Wait, so then with that formula, could they figure out how fast he was going?
Yeah, they could figure out how fast he was going. Yeah, if they have the opposite information. So if they have the coefficient of friction and they know what D is, they could find out how fast he was going. Yeah. All right, this is the last problem. Take a look at page 562B. This has to do with construction. Now listen to this. Right now, I don't know if you've been out, I live in East Highlands, so they're expanding the freeway, and they have these huge I don't know, tractors that are lifting these steel beams. Now, what if the rope breaks? You could kill the cars underneath. I mean, there could be a disaster. Somebody could die if the rope or chain breaks. So let's take a look at this problem. The diameter D of a rope needed to lift a weight of W tons is given by this formula. How much weight can be lifted with a rope with a diameter of 1 inch? Because you want to make sure this rope is gonna, how much weight can it hold? You're not gonna just sit there and guess like, oh yeah, the rope's gonna hold 3 tons. Because like I said, it'll snap and drop whatever it's holding if the weight isn't right. I don't know, you guys probably don't know this, because when you buy a house, you're gonna hang pictures on the wall. Well, there's certain anchors, when you buy the anchors for the wall for the pictures, it says how much weight it'll hold. And if you don't buy the right anchors for the picture, it'll pull it from the wall and crash to the floor. So you have to make sure that when you're hanging pictures, that however you're hanging them, if they're heavy, you want to make sure the anchors are going to hold it. All right, so here's the formula. Pi is just a number, right? What's D in this problem?
One.
The diameter of the rope, right? And we're finding W, correct? So we're solving a radical equation. So look what I'm going to do. I'm going to put this over 1 and cross multiply, or you can multiply both sides by pi, set up a proportion, multiply by pi. So I'm going to get square root of 15W is equal to pi. Cross multiply, right? I did not say cross cancel, I said cross multiply. So I'm going to square both sides. And on the left side, I get 15W. And what is pi squared, guys? And I'm not going to round too much. So tell me what pi squared is.
9.86, and then it keeps going.
Yeah, and you know what? I'm not even going to round right now. What I'm going to do is I'm just going to write it like this, the exact that, and I'm going to wait until I divide by 15. So I'm going to get a more exact answer. Okay, so now on your calculator, what's pi squared divided by 15?
.657.
It's about 0.66, right? So what does that tell you?
Wait, Ms. Birch, can you explain how the D turned into 1/1?
Any number can go over 1. 7 could be 7/1, 8 could be 8/1, 9 could be 9/1. So that's what a whole number is. It's a number over 1, and I put it over 1 so I could cross multiply because I formed a proportion. So a rope with a diameter of 1 inch can hold about 0.66 tons. So that means about 7/10 of a ton. right? 7/10. So you know what that means, right? If you try to lift something over a ton, the rope's going to snap. So if you're going to use a rope that's 1 inch in diameter, it's like that thick, you better stay under a ton, because if you go over a ton, you're going to lose whatever you're trying to hold. Okay, that is the lesson. And what we're going to do now, I'm going to go in and take attendance in the wizard teams. What I want you to do in your team is I want you to work on the practice AB, and we are going to work on this on Friday. So don't finish this, okay? So you're gonna work on the assignment. You can do the online, but whatever you finish today in class, we're gonna save it for Friday. All right, so we're kind of out of time. I mean, class ends at 10:45, but you could do at least 2 or 3 problems of these. All right. All right, anybody want to ask me about anything right now? So I always like to show real life. I don't believe in making up word problems just to make a problem fit. That's why we don't work problems in every section, because it's like they're just trying to take math and make it fit. But these are good problems because these could actually happen in real life. You know, the skid problem and this construction problem. All right, I'll see you in the Math Wizard teams. Make sure that you ask me questions if you have questions about anything I did in class. All right, and I'll be taking attendance. We will not report back today, but I'll be checking with you in your teams. All right, you guys.